Well, hello friends. Today we are going to make a syscall, and specifically we are going to make, it's called writev, and I just learned about this and it seems really neat. So it's basically the same as write, except you can write multiple buffers with one syscall. And I thought that sounded really neat because I have this code in the Windows Server communication where we're sending occasionally like multiple buffers at the same time that make up an individual message. And it kind of annoyed me that it was two calls to write when I was doing that. So here's one, for instance, in post message to server. This is when the libgui client sends a message to the Windows server. Then first we'll call write, passing the message, and then if the message has some extra data, then we would do another call to write, passing that extra data. So it would be really cool to do this as a single call to write v. I guess that's write vector, right? So let's start by, I guess, typing up what the code would look like here. I guess I write v as event fd. Probably this thing should be renamed to something else, but not now. And we need an IO vector, so I guess IO vector and 2. Or no, wait, hold on. You count. Wow, that's a terrible name. So let's see. We'll destruct the IO vec. And we don't actually have that struct, so what does it look like? This. Okay. So let's go ahead and add it. It should be in sysuio.h. Okay. Let's see, sysuio.h. Refresh. Okay. And let's edit that. Okay, so this is how I normally do libc headers. Begin decals, end decals. So these are just macros that do extern C, but they also happen to be the same name as the macros used by glibc, which helps when porting third-party software that expects these things to exist. Okay, so then let's just do struct iovec, blah blah blah, void star IOV base and size t IOV flag. Great. I guess we can include types to get size t. Cool. And let's also add the prototype for this function. So int fd const struct iovec and int iovec count. Let's call it. Okay, and then what should this look like? Oh, we need a UIO CPP as well. Okay, and we'll include sysuio. And here, for some reason, or not for some reason, here I just do this. I don't need a fancy macro because I control this whole file. So then we'll just do this syscall. And for that, we are going to need kernel syscall. Okay. Syscall sc writev. And we're going to pass it. Oh, I see. I guess that's why the name was that way. Well, whatever. Okay, like that, and then, oh shit, we're gonna need error now as well. Turn with error now RC, like that, right? So -1 on error. Return value is -1 on error, blah, 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 blah. Otherwise, the number of bytes that we wrote, right? Just like write. Okay, Cool. I think that's cool. Then now we gotta add the syscall. So first we start here, add a new syscall to the big list, and then we also have to dispatch the syscall. So sc writev, return current process, sys writev, and then we cast all the types. What was that? Const struct ioback, arch2, and int arch3. Okay. And then sys, oh no, hold up, process.h. Where's, I guess we can put it next to sys write. Yeah. Okay. This makes me realize that I actually need to define this thingy so the kernel can see it as well. So I'm gonna put that in. I guess I'll put it in the Unix types header. It's like this catch-all header where I just put anything Unix related that the kernel needs to know about. Oh, yikes. My disk is filling up. Okay, so now we have this thing here. Now we can actually handle the syscall. So we do, actually, let's go next to write. Okay, we'll say size t, construct ioback iv, int iv count. All right. So first thing we're going to do is validate that we can actually read from this vector here. And we're going to do read typed, and the count will be this. So this helper here just figures out how many bytes to verify based on the type of the argument. A little template helper. If that doesn't work, then we say default. And then we want to do this. Okay, now we have the descriptor. I guess, should we just do what the existing write is doing? I guess maybe the best thing would be to factor that out into a helper. Let's see, let's do like this. Process, do write. We'll say file descriptor, and data, and data size. And then this code will do, I guess this much. Okay, and then we'll say written is to write. Data size. Okay. And private. Just put that here. And that's redundant. Okay, there we go. Now this is a reference, and U2, U3, U4. Cool. And then data size was the new name of that guy. Okay. You and you. We don't need to actually cast here or here. Okay, I guess this is looking pretty alright. Then what would this guy do? We would do for int IOV count, and then he would just, we need to accumulate this in somewhere, and written 0, okay, and we'll say, oh, we should probably see turn in if sum of IOV is greater than max size t value. Max. Yeah. Okay, and oh, and actually this one's easy. Less than 0, or I guess we can allow an arbitrary amount for now, but we'll do that here. And this goes here. Okay. And then plus equals to write, or no, hold on. Let's see. Base IOV len. Okay. So if we fail, so what do we do if we fail halfway through? I guess we treat it as a partial read, or partial write, rather. Okay, so that would just be, wait, what's wrong with you? Oh, gotta cast it. Byte. Okay. Turn RC. Turn written. Yeah, so if we get an error and do write, then if we didn't write anything at all yet, then we'll just return the error. Otherwise, we'll return whatever we wrote so far. Yeah, that sounds good. Otherwise, we'll do written plus equals RC. Cool. I like that. I do like that. Okay, so what was this again? Now we're back at the client side. So first thing we gotta do is include sysuio, and then I guess IB 0. The base is going to be message, and IOV len is going to be size of. Oh, well, whatever, deal with it. And I guess this would actually be a bit easier like that. Yeah. Oh, hold on, and this isn't right. And then we'll say IOV count is 1. Why don't you like it? Struct IOVec. Oh, right. But then for the second one, that one is optional, so we just do, I guess, this. That, and we say IV1 base is extra data dot data. Extra data dot size. And what's wrong with you? Are you also const? Yes, of course you are. But I'm just going to cast that away. Haha. Okay, and I guess we can do something like assert and written is equal to size of message plus extra data dot size. Plop. Now, will this work? Will it even build? Who knows? Let's find out. What were we doing here anyway? And write syscall. If the descriptor is blocking, then we do all this business. Otherwise, we just do this, and we don't return and written anywhere, so that's clearly a mistake. And we forgot to edit the libc makefile to add the UIO thingy. Sys UIO. Okay. And is there something else I'm forgetting? This code is structured in a really dumb way here, so I'm gonna fix that right now. So if it's not blocking, then we can just do this, and that's all there is to it. So that, and then this stuff we can auto indent. Boom. Nice. Does that even make sense? Okay, I don't know. Oh, forget about it. Right, so for a blocking call, then we will try to write it. And if we can't write, we'll block. And when we unblock, eventually we will write it. And if it fails, we'll return the error. If it gets as a 0, we just break. And if we have an unmasked pending signal, then we return enter if nothing was written. Nothing was written. Oh, yeah, right, because otherwise we return however much was written, and then we'll deal with the signal a tiny bit later, I guess. That's fine. Okay, let's see if this works. I guess the way that we would see that it works is that that it doesn't do this. So we're getting the assertion here. So that's not a great sign. Let's see what we screwed up. So we're calling writev. Guess we can print it out here actually, what we are doing. Print writev. P and number, right. And we can even say how much got written because we know it. Okay. Unknown function 98 requested. So what did I screw up? Oh, look at that. I didn't actually save these changes. See the red here? That's freaking subtle. So the syscall never ends up in the kernel. That's so weird, but it does make sense. Yeah. Okay, let's try that again. And everything's coming up, and we see all those glorious writev syscalls. And things are just working on like they would normally, but sometimes we send 2 in one go, and it just works. How cool. Okay, let's see. I think there's another site that does exactly the same thing. So we did the GUI client side, but now we can also do the Windows Server side of messaging, which is here. So we'll just do kind of exactly the same thing here. Post message. Okay. Yeah, see, I always dislike this here because it's like doing the same stuff twice. So this will be quite nice to do in a single syscall. So I'll do it like this, and then I have a count, this one. See if I can do this without peeking at the other code. I think I remember how it works. String data, it's empty. And I'll say IOV. I see, I'm making the same mistake twice. Extract data, IOV1, IOV. And then we'll just say writev. Count. Say writev here. And this should be plus extra data size. That's really pretty cool. Yeah. Okay. Let's see that we wrote everything the same way. Yeah. I was just checking if I was using isEmpty here as well, which I did. Okay, so let's rebuild everything, because now we're using writev on both sides, and I think that's pretty cool. I think that is pretty cool, actually. But there was one thing I just wanted to have a look at. Here, if we have an unmasked pending signal, we should probably do the same thing in writev. Actually, if there is a pending signal when we exit, then we should immediately handle it. Yeah, okay, I'm going to do that at the end of writev as well. Maybe this should be factored differently. I just want to make sure that we take care of signals. Okay. And looky look. Seems like all the messaging is happening between the Windows Server and the clients in this new magical writev land. It's working just right. Freaking cool. All right, so let's do a patch review. See what we've done. Okay, so this is writev implementation. Right, so if we have a negative number of IO vectors, then of course we return E and val. And then we also validate the IOVec array, otherwise return E fault. And we add this fix me because I'm lazy. And then we get the descriptor, and then for each IOVec array entry, we do a call to do write, passing in the IOV base and the IOV len, and if we have an error, then we return the error in case nothing else is written. Otherwise, we return a partial write, and then we accumulate the bytes written and written here. And then also, if there's a pending signal when we finish writing, then we move the thread to blocked signal, which just means that next time that we hit the scheduler, we are going to dispatch that signal. So blocked signal is a very, very short-lived block state. And if there was nothing written, then we return enter. I'm not sure. Maybe that should only happen if you're blocking write. But whatever. Not going to worry about that now. Okay, so then do write. We were just factoring out what was previously in the write syscall, separating that out into a function so that we can call it from writev. And then, of course, also reorganizing a bit so that we have an early return here instead of nesting for the non-blocking case. Okay, and then syswrite. Yes, we just see here that we lifted all of that code out and put it in a helper do write. Okay. And then here's the new declaration of the writev syscall. Here's the helper. And then here in syscall cpp, stuff that we forgot to save. It's the writev dispatch. And here's it. Here it is in the syscall table. Okay, and then the Unix types for the kernel, we have the iovex struct, so the kernel knows how to use it. And finally, some call sites. Okay, so the G event loop code, post message to server. We now create an iovex array with the message and the extra data optionally, and send those together. How neat. And we just assert if it fails. I think that's fine for now, but like maybe there should be some more graceful error handling here, but I don't know what that would be really, so I'm just letting libgui apps crash if they fail to do I/O. In the Windows server, this should probably not crash if the I/O fails, but that's something that I'm going to have to do a big overhaul for anyway, so I'm not going to do that right now. But we do exactly the same trick, that we just accumulate the message and the extra data into an iovex array and write it all in one go. Get rid of this duplicated error handling here for 2 writes and assert that we wrote everything at once. That's it. That's the whole thing, and it freaking works. How cool. So let's commit and say kernel. Add a writev syscall for writing multiple buffers in one go. We can use this immediately in Windows Server communication in order to send both message plus extra data optional. Can we then use this immediately? Right. Okay. Cool. Let's push it. Oh, that never works. Oh, it worked. Okay. Yep. Everything is working dandy. Very cool. Very cool. Okay. So if I think that's gonna do it for today's video. So if you made it this far, then I thank you for watching and for coming back, and I hope you saw something interesting today, and I will see you next time.